The other principle that we need to talk about here is the additivity principle. So the additivity principle says that we can add two areas of a shape together to make the total area of that shape. So basically, let's look at this shape here as an example. So we can't easily calculate the area of this L-shaped figure, but what we can do is we can subdivide this shape into two rectangles, and we can find the area of rectangle number 1 here, and then the area of rectangle number 2, and we can add them together to be the total area of our shape. Now, the tricky thing here is remembering that we're going to multiply one side times another side of the shape to get the area. So fortunately, we have one side here that's 16 feet and one side here that's 28 feet. So for shape number 1, the area is 16 feet times 28 feet, just like we would calculate the area of a rectangle. And if I get out my handy dandy calculator, I can find that that area is, so the area of shape number 1, rectangle number 1, is 448 square feet. So now we're going to find the area of rectangle number 2. And in this case, we use this side, 20 feet by 30 feet. So 20 feet times 30 feet. And I can actually do that one in my head. That would be 600 feet squared. And so our final is to find the whole. This is where we use the additivity principle. We're finding the total area of the shape. So we would take 448 square feet, and we would add it to 600 square feet, and we get a total of 1,048 square feet for that whole area. Another thing we can do with the additivity principle, I know it sounds weird because we're calling it the add is in the word additivity, but we can also kind of call it the subtractivity principle. So for example, in this shape here at the bottom of my screen, we are going to, in this case, take the whole area of this rectangle, and then we want to know the area of the orange part. So we're going to take the area of this smaller rectangle, and then we're going to subtract the 2, because this is like a little hole in the whatever it is, the patio or something. Maybe it's a pillar that's in the patio. So just like in the additivity principle, we're going to take the area of the orange part, and that is 3 centimeters times 5 centimeters. So we end up with 15 centimeters squared. And then the interior little rectangle is 2 centimeters times 1 centimeter. And that gives us 2 centimeters squared. And now we're going to subtract the 2 to find the difference. And we find that the orange part is 13 centimeters squared. So hope that helps you with some of these more complex figures.